Hey YouTube, it's Rob. I have a video here for you today. I also want to welcome any new viewers to my channel, and I'd like to welcome anybody from the geology forum here. There's a lot of cool stuff here that you might be interested in. And well, I would like to start out with something simple. Plate tectonics says that there's a mid-Atlantic ridge here running between these two continents, and that seafloor spreading is taking place, and somehow molten magma is pressing up between these plates and pushing them apart, which doesn't seem to make a lot of sense, because with that kind of pressure, I would almost bet that every volcano in the area would blow off before it would push this apart. Usually takes pressure will take the easiest place, the easiest direction, it can go. And most likely it would be out like volcanoes and stuff like that. And I just don't see that's realistic. And to top it all off, if you line these up like they claim, that the mid-Atlantic ridge spread these apart, you can see that they don't really fit very good. I mean, they look similar, but that's about it. I can see that maybe fits there, but then you got these gaps up here. But that's good enough though. In plate tectonics, that's acceptable. Well, let me show you something though that defies plate tectonics, and eventually I want to show you what made this planet. Let's go. Hold on. Okay, you saw the alignment that I made with plate tectonics. This is the mid-Atlantic ridge right here. Now I told you that the seafloor spreading was taking place here and all that, and I showed you their alignment. Now, if what they say is true, then how come I can take this and line it up like that? Okay, let's take a closer look at this. Yeah, like that. And you can see that the Amazon River is not made by gravity or erosion. It's made by electrical discharge, because you could tell that each one of these islands here is a point of discharge as it came around. You can see that this actually, both these areas actually sit in one another, and what I can do over here is what I can do over here, because they're the same area. They're just different layers of the same area, but you can see that clearly these are related. And when I bring it over here and line it up here, you can see that it starts to line up in here. It's electrical discharge, and these are reoccurring patterns of it. See that? And you saw what plate tectonics looked like when I aligned South America and Africa. Now look at this. This is precision compared to that. I mean, think about look how this fits right in here, and then the electrical discharge reaches out across and hits these. Look at it, even right there where it's missing mountains and stuff. You can see the electric discharge running through there, and you can see it lining up with some of the discharge marks on the land. Making here. possibly over here too, I think. Once I move, because you know this moves closer, by the way. So that's pretty trippy, right? You know that I never heard that in geology. And then not to bash on geology, but you know, it's time for a change. You can see the swirling going on in here. Also, this same area that lined up over here lines up over here, and you can see those mountains right here. These mountains are not regular mountains. What makes these mountains different than other mountains is that on other mountains you never seen mountains cross over mountains before, right? Because that's what these do. This crosses over on top of this one that's going underneath, and then as it crosses over, you can see that it swings back around, and then it goes underneath. You can see the layers right there as it goes underneath. It's cutting in, and then you can see, of course, the high temperature. This is like a short. These are Birkeland currents, and the electric universe theory talks about these all the time, running from star to star to planet, and they power them up, is what they claim. And I think this is pretty good evidence that they not only do they do that, but they possibly could make our planet. These ones I think made ours. But you can see it crosses underneath, and then it like shorts out. You could tell. Then all of a sudden you see this electrical, big time electrical marks. Electricity obviously is what makes mountains. It just does. You can just tell. There's no collisions here. Collisions don't make smooth round mountains like this, but Birkeland currents frozen in matter would. And you can see there's two of them, which is normal for Birkeland currents. But you can see that these Birkeland currents are related to this area right here. As a matter of fact, it sits inside of it. Right, like that, right? Okay, but that's not the only thing. And then of course you could see that this area sits in here too. It moves all around. You can see there's a similar shape here, right here. Maybe smaller or something. But yeah, you can see it right there. You can see how they're related. But that's not all. Check this out. Okay, here's that same area. It's just tilted a little bit so that I can line this up better. And here you have the Himalaya mountains. Okay, you see how the Himalaya mountains line up? And you can see the Himalaya mountains have an overspill right here. You can see how these islands right here line up with the mountains in the Himalayas with the tech. You can see that the same distance apart. When I move them back and forth, you can see that. You can even see they line up with the lakes up here. Right? And these are opposite sides of the planet. I've showed this before in other videos. Also, you can see that this lines up in here. It just lines up everywhere. And then of course this part right here, this guy fits right inside there. Like, you can see the texture and everything line up right there. And then these round areas, these knuckles right here, you can see that they line up in here. And so does the texture here. You could probably take it all the way down into here and line up, because this moved around like this. You could just tell as it was spinning. And this will also reverse and fit the other way too, because it's spinning. That's my proof that it's spinning, because I can spin it around and fit it the opposite. I can fit it the opposite way. There, I reversed it. Let's see here. There's this right there, fits in there too. But was moving over here, and you can see that it fits in there. I could even straighten it out some more, but I think it fits better. Like, well, I guess it can fit either way. It looks like it fits it here, and then you could this inner. There's like two of them here. One outer one and then one inner one, and the outer one fits that way, and the inner one would have to turn a little bit. But you can see that it lines up right there, everything. And then on top of that, well, it lines up here too. But you can see that it lines up here. Actually, it's supposed to go the other way, but this way works too, it looks like. But yeah, you can see it here lining up all the way here. Oops. Alright, so you kind of get that idea. I could go over this more, and I probably should. Like, for instance, this looks like a fault or something here. I have something about that too. I'll have to show you later, but you can see it lines up. Kind of. Yeah, it lines up. You can see it lines up when you line other things up around here. So that's that. And it lines up, of course, everywhere. You back it this way, it lines up, go this way, because this made everything, so it's going to line up all the time. So there, okay, okay, that's that. And then of course you remember the Birkeland Current mountainside claim. They're what gouged that out to begin with. You see that, how it lines up the knuckles, the ridge part, this eye looking thing, this triangle eye goes right into there. And you can see the mountains themselves twisting around, fitting in with the turbulence that's over here. You can see how it fits around this lake or whatever. It's because This is plate tectonics can't be right. I mean, this is the opposite sides of the planet, and this is observable evidence, and it not only doesn't line up, it's showing you what it did. It rotated. It's creating this planet. It's a vortex. This is the beginning of it, of the vortex. And I believe this is what our core of our planet looks like, Birkeland currents, but plasma. These are just encased in matter here, like a statue. But they're an image of the actual event. But, and then of course the Amazon discharge pattern plays a key role in all this too. You see how it fits up everywhere? It's reoccurring patterns of it helped create this planet. It's this electrical event. There's no doubt about it. Look. Okay, so that's that. Okay, I just wanted to show you Australia really quick here. You can see these teeth marks here. This looks like an alligator or something. But when you go through, you can see that the land features of Australia also line up with these marks, like right here. You see the dots and the half circle pattern. You can even see the lines lighting up too, and it almost looks like if you're it took a chunk out of this. Like even these marks where it looks like it got shredded off, they line up with those islands. Kind of trippy, huh? Alright, well, what I really want, and then of course when it takes the chunk out of there, you can kind of see how this is similar in shape right here. But that'll be for another time. Oh yeah, and then of course the spinning vortex here, you can see where it fits in here. Once I clean this up, but I just wanted to quickly show you this. I didn't want to spend much time on this because I'm running out of time. I really wanted to show you Africa. Okay, what I'm going to show you is that the continents came out of this area. And I wanted to show you with Africa, this is the inside of the vortex. You can tell the spinning is there. This is actually going to be, I'm pretty sure, South America right here. And it's just, all it is pointing the wrong way. It just needs to rotate, and that's it. But I wanted to show you as it comes in. I'll line these up right here. There's that vortex. Yeah, I think this goes in. You can see how it goes. It fits in here. The discharge right here. Remember? Oops. You combine the two and look what you got. They match up. See that? It's pretty cool, huh? That's more than enough information to tell you that plate tectonics isn't right. But what's going on is, as you bring this in, okay, it comes in like I said, it's reoccurring, so like you can see the vortex spinning here. But bring this in here. And then you can see this lines up in here. This is really hard for me to explain, but Oh yeah, I think this reverses. That's right. Hold on. Okay, I wanted to show you something unique about Africa, the south tip. If you zoom in close, you'll see that it looks like this is sitting in layers. Okay, like 1, 2, 3, 4. It's obvious. These are sitting in layers. This is obviously that overspill. I can guarantee. I can just tell by looking at it. And but it also looks like a saw came through here and just buzzed the crap out of it. I mean, you can even see the little nicks taken out. Looks like, and it just looks like yeah. And it's got these teeth-looking things right here. I wonder if this could be where it's folding, but I'm not sure yet. Some really unique land features out here, by the way. I don't know if you've ever taken a close look of Africa here, and you'll notice it's got some unique features. Looks like, to be honest with you, this looks like it's sat below something. And this is the bottom piece of the top piece. So if this other side is flipped around, these could be valleys and stuff like that. That's something I'm going to have to look into later. But look at this crazy looking features here. Okay, so all the way down to the ocean, just layer by layer. That is cool. Anyways, let me get back to it. I have to look into this more. So here it is reversed, and it still lines up with the discharge. Fits into here, but I think it's this other one that's more accurate. I think because it fits into here, but it also fits. I think what's happening is that this is curving, and this is going to fit into here. It's kind of like how it came out. You could see that. Well, let's see here. That's the other one. Crap, hold on. Yeah, this is the more accurate one because it's a straight-on shot of Africa. But you can see these markings here, and you can see that this swirl right here, this is that vortex again. Every time you see that, I think that's the inside of the vortex, and you can see it's curving, it's rotating around. See how this lines up? I think everything, what is going on here, check this out, we'll do it like this. Okay, this is this part, lines up here. This is fitting into here, I guess. And what I think's going on is that I think there's a tunnel. I think there's a tunnel in Antarctica, and I think this is going to go here, of course. Yeah, check this out. Okay, can you picture that inside of this is the spinning part? Antarctica, that peninsula, is actually the one that's rotating inside of here, and this is like the outer plasma sheath or whatever, I don't know. But what I think's going on, see how it lines up like that, is that I think because this is a vortex, that just looking at Antarctica, it just looks like it's going in right here. It looks like it's concave. This obviously was spinning around when it came to a halt. You could just tell that it's rotating at one time, maybe during a cataclysm. But it almost looks like that this sinks down, and this Antarctica is just sitting on top of it, but it's actually concaved in. And I almost positive from now that I'm used to seeing reoccurring patterns that I'm guessing that there's a tunnel somewhere down in here that they ain't telling us about. And I think that this is kind of its reoccurring pattern. I also think that the Red Sea might be the reoccurring pattern for it too also. Right here. That might be how far that tunnel goes in. I'm just saying, because this dot right here, I think that's maybe the size of the tunnel itself. You can see it's similar in size here in diameter. And my pattern's based upon reoccurring patterns, so it might even be that the Antarctica is concaved in like that. You know, if you look at it from the side, I don't know yet. I have to figure that part out. But anyways, that's what I've got for you. You can clearly see that plate tectonics isn't the way it is. None of what I showed you could have lined up if there was plates in the ground, because things are rotating and swiveling. It's just no way of it. Not only that, you've seen my evidence for electrical discharge. Large river systems made from gravity don't have reoccurring patterns of themselves. They're usually unique, right? Erosion in water and gravity are unique features. They don't replicate themselves like electricity will when it burns through layers. Like the layers I showed you in Africa, if you have a discharge across those layers and then you pull them apart, you're going to have reoccurring patterns of them. And I guarantee you, there's reoccurring patterns of the Amazon River all over the planet. It lines up everywhere, here, everywhere. As a matter of fact, this gouged it out. The base of the Amazon gouged this area out right here. And that's for another time. Thanks for watching.